This is Lecture 1, Theory Building and Deriving Hypotheses. By the end of this lecture, you should be able to understand how to apply the scientific method to political science research, know how to formulate a scientific argument, know the difference between an independent and dependent variable, know how to derive a hypothesis from an argument, know how to graph the relationship between two variables, and understand the role of evidence in the scientific process. This semester, you are taking an advanced research methods class in political science. Before we talk about these methods, we first have to discuss the scope and goals of political science itself. So what is political science? Political science is the study of politics in a scientific manner. Politics deals with any outcome that is related to public decision-making. These outcomes can include many topics, such as voting behavior, the legislative process, or interstate war. Political scientists use the scientific method to describe these political outcomes and explain why these outcomes occur. There are 5 steps in the scientific method. You will be following these steps in your research project this semester. The first step is to ask a research question. In this research question, you will identify a dependent variable or political outcome and explain why variations in the political outcome occur. For example, you may be interested in interstate war. You would ask, why do some states go to war while other states are peaceful? Note that this question is a general question, not a specific question. In this case, we want to know why states go to war in general, not why a specific set of states went to war. In the scientific process, we are interested in creating general theories that apply to many outcomes, as opposed to trying to explain specific outcomes. In addition, note that the question focuses on many levels of the dependent variable. Instead of just asking why states go to war, we also want to know why states don't go to war. It is very important to look at all levels of the dependent variable when trying to explain why variations in the dependent variable occur. The second step in the scientific process is building a model to explain why we see variations in our dependent variable. In this model, we usually choose one independent variable that we believe influences variation in the dependent variable. We believe that variations in the independent variable influence variations in the dependent variable. We have to be specific about how we think the independent variable influences the dependent variable. We state that the independent variable has a positive effect on the dependent variable or a negative effect on the dependent variable. If we believe the independent variable has a positive effect, we believe as the independent variable increases, then the dependent variable increases as well. If we believe the independent variable has a negative effect, we believe that as the independent variable increases, then the dependent variable decreases. For example, imagine our dependent variable was interstate war and our independent variable was interstate trade. We could say that as trade between two countries increases, the likelihood of interstate war decreases. Not only do we have to explain how our independent variable influences our dependent variable, we have to explain in detail why our independent variable influences the dependent variable that way. It could take several pages of text to explain why the dependent variable to explain how the independent variable influences the dependent variable. You have to be very specific about the process in which the independent variable influences the dependent variable. Explaining why an independent variable influences a dependent variable is a writing skill that you will develop in this class, but you will develop much further in other upper division political science classes. Additionally, note that our theories do not have to include every independent variable that influences our dependent variable. Our theories are simplifications of the world. We only focus on a small number of independent variables that influence our dependent variable. We don't have to focus on every factor that influences our dependent variable because other studies have already done that. The third step in the scientific process is deriving a hypothesis from your theory. A hypothesis is a one-sentence statement that describes how the independent variable influences the dependent variable. It tells us whether the independent variable has a positive or negative effect on the dependent variable. Once again, if the independent variable has a positive effect, then as the independent variable increases, the dependent variable increases as well. If the independent variable has a negative effect, then as the independent variable increases, the dependent variable decreases. In addition, the relationship described in the hypothesis has to be observable in the real world. We should be able to collect data and determine if the independent variable influences the dependent variable in the way we expect. There are several different ways to write hypotheses. In the next few slides, I will provide you with some templates on how to write hypotheses. First is the more likely than, less likely than template. This template is useful when you have an independent variable that has only two categories and a dependent variable that only has two categories. For example, imagine your dependent variable was party identification. It only takes on two categories, Republican and Democrat. And your independent variable is gender, which also only takes on two values, women and men. You could write, women are more likely than men to identify as Democrats. Note that this hypothesis identifies how variations in the independent variable, women/men, influences variations in the dependent variable, identifying as Democrats versus Republicans. In addition, we can observe this potential relationship between party identification and gender in the real world. We could conduct a survey where we ask respondents their party identification and their gender, and then determine if women are more likely than men to identify as Democrats. The next hypothesis template is the more than less than template. This template is useful when you have a dependent variable that is continuous and can take on multiple values, and an independent variable that can only take on two categories. For example, imagine your dependent variable is defense spending, which could take on any positive dollar value, and your independent variable that only takes on two categories, whether a country is a democracy or dictatorship. Our hypothesis could be, dictatorships allocate more resources to defense spending than democracies. Note that the hypothesis identifies how variations in the independent variable, democracy, dictatorship, influence variation in the dependent variable, defense spending. In addition, we can observe this potential relationship between democracy/dictatorship and defense spending in the real world. We could collect data from public records on countries' defense spending and collect data on whether countries are democracies or dictatorships. Then we could determine if dictatorships spend more on defense than democracies. The last template is useful when we have an independent variable and a dependent variable that are both continuous and take on multiple values. It is the independent variable increases/decreases, dependent variable increases/decreases template. For example, imagine our independent variable is the per capita income of a country and our dependent variable is defense spending of a country. Our hypothesis could be, as the per capita income of a country increases, the amount of resources the government spends on defense increases. Note that this hypothesis identifies how variations in the independent variable, per capita income, influence variations in the dependent variable, defense spending. In addition, we can observe this potential relationship between per capita income and defense spending in the real world. We could collect data from public records on countries' defense spending and collect data from public records on per capita income in those countries. Then we could observe whether a country's per capita income increases, their defense spending also increases. It is easy to make mistakes in hypothesis writing. A common mistake is not correctly identifying what the independent variable is. For example, you could say, some countries are more likely to go to war than others. But which countries exactly? What specifically leads some countries to be more war-prone than others? Another mistake is not focusing on how variations in the independent variable influence variations in the dependent variable. You could say, democracies have high standards of living. But you're not comparing democracies to anything. High compared to what? Instead, you could say that democracies have higher standards of living than dictatorships. This is a comparison where you're comparing how variations in the independent variable, democracy/dictatorship, influence variations in the dependent variable, standards of living. If you are having problems determining whether you wrote an appropriate hypothesis, you could draw a graph based on your hypothesis to see if it is an appropriate hypothesis. On the y-axis, you would place your dependent variable, and on the x-axis, you would put the independent variable. You should label the appropriate values on the axes and then draw the relationship between your variables based on your hypothesis. So imagine that your hypothesis was, as the per capita income of a country increases, the amount of resources the government spends on defense increases. This is what the graph would look like. Defense spending is on the y-axis. Per capita income is on the x-axis. And as per capita income increases, so it's going this way, defense spending is also increasing, resulting in a positive slope. At this point, we will only be focusing on two basic types of relationships between independent variables and dependent variables. The first relationship is a positive linear relationship. As our independent variable increases, our dependent variable should also increase. And this increase should be constant across all values of the independent variable. The effect that a change in the independent variable has on a change in the dependent variable is the same at low values of the independent variable and high values of the independent variable. In other words, the slope is constant across all values of the independent variable. The second relationship is a negative linear relationship. As our independent variable increases, our dependent variable decreases. And this decrease is constant across all values of the independent variable. The effect that a change in the independent variable has on a change on the dependent variable is the same at low values of the independent variable and high values of the independent variable. In other words, the slope is constant across all values of the independent variable. The fourth step in the scientific process is the empirical analysis. In this step, we collect data to determine if our independent variable influences our dependent variable. In this class, we will focus on large N designs where we collect a large amount of data across many cases to analyze the relationship between our independent and dependent variable. There is another type of design called a small N design, where scholars only focus on a small number of cases to analyze the relationship between the independent and dependent variables. In the fifth step of the scientific process, we evaluate our theory, our hypotheses, and our empirical results. We think about what we could improve upon or what other research we can do based on our results. In addition, it is important to note that we should not overvalue our evidence. Just because you find results in one study, those results need to hold up in other studies for us to be more confident that our independent variable has an actual impact on our dependent variable. Also, just because we don't find results that support our hypothesis doesn't mean our hypothesis is wrong. There are several reasons, many statistical, that may lead to no results. We will be spending the second part of the semester talking about these issues and how to address them. You will learn how to make more sophisticated statistical models to test your hypotheses.